ఇగో ఇక్కడ కన్సిడర్ 01 knapsack ప్రాబ్లం. ఇప్పుడు బెల్మెన్ ఫ్రోడ్ ఆల్గోరిథం ఉంది. దానిలో సింగిల్ సోర్స్ ఆర్డర్స్ ప్రాబ్లమ్, తర్వాత 0 or 1 knapsack ప్రాబ్లం దగ్గర మాట్లాడుకుంటున్నాం నిన్న. సో దట్స్ వాజ్ వీ హ్యావ్ టు డూ టుడే.
आप सब मेरे लिए काम करेंगे. करेक्ट. रिसर्च एनालिसिस करके स्टॉक्स recommend करेंगे.
Start taking the decision of the last object also include. The problem is 01 knapsack problem. In this video, I will explain what is 01 knapsack problem and how it can be solved using dynamic programming. We will understand its approach. Next, I will show you a tabular method for solving this one. Then also I will show you a sets method for solving this one. So there are two methods. We will see both the methods. First of all, let us understand what the problem is. Here I have some 4 objects. For each object there is some profit and there is some weight. And there is a bag of capacity M, that is 8 is given. The objective is to fill this bag with these objects. So can I put them all? See, the capacity 8 is 8, but the total weights of all these objects is 14. So all objects cannot be filled in the bag. So I have to carry few of those, some of those objects, like subset of those objects, and I have to carry them and sell them at other place. So once I sell, I get this profit. So I have to fill the object such that the total profit is maximized. And I have to get the solution in the form of a set for each object. Like for example, this is included and this is not included, or not included. Like this, I have to write down which one is included and not included. So it means I can write down each xi either 0 or 1. It means the values can be 0 or 1, but not fraction. So it means that the object that I am going to carry are not divisible, breakable. So I cannot take the fraction of that object. So this means these are some solid objects. Maybe a mixer or microwave oven or a router. It can be something like this. So which I cannot take a half of a mixer in the bag. So these are indivisible objects. So either I should carry the whole object or don't carry it at all. So I have to carry the object such that the sum of their profits should be maximized and sum of their weights should be less than or equal to the capacity of the bag. Now let's know the approach of dynamic programming for solving this one. A few important things about dynamic programming. Dynamic programming is useful for solving optimization problem. Yes, this demands maximum results, so it's optimization problem. Second thing, dynamic programming says that the problem should be solved in sequence of decisions. So yes, we can take the sequence of decisions for every object we can take, shall I include or not, include or not, include or not. So I can take decisions. I can even start taking the decision of the last object also, include or not, include or not. So usually in this one we take the decision from last object towards first object. So we can take sequence of decision. Next thing, one more point that dynamic programming says that you should try all possible solutions and pick up the best one. Now how many possible solutions are there? See, when I'm writing the solution in the form of zeros and ones, then it can be 0, 0, 0 means no object is included, or 1, 1, 1, 1 means all objects are included, or 0, 0, 0, 1 means only fourth object is included, or first object is included, or first 2 objects are included. Like this, there are many possible solutions, and some of them may be feasible, some may not be feasible. Like all objects I cannot include. So anyway, I should try all of them and pick up the best one. So total how many solutions will be there? So like 4 zeros and ones form if I continue, so I'll be getting 2 power 4 solutions. So I should try 2 power 4 solution. For n objects, it will be 2 power n solutions. So if I try out all, then the time complexity will be 2 power n. This is too much time consuming. So dynamic programming shows an easy method for doing the same thing. We will be indirectly trying all 2 power n, right? But not directly. So we will not spend that much time. Let us solve this problem using tabulation method. Tabulation method, let us see how to fill these values and how to get a solution for this problem. So for solving, as the capacity of the bag is 8, so I have taken the columns starting from 0 to 8. So this means that though the capacity is 8, but we'll not consider that 8 at once. So we'll add weight 1 by 1. So starting from 0, then let us assume weight is 1, weight is 2, and so on. Then rows, 4 objects, so I have taken 5, 0, 1, 2, 3, 4. So starting from 0. So it means 1 by 1 we will consider the object. So initially we will not consider any object, we will not include any object in the bag. So for filling this, we have a formula. So I'll show you formula after some time, after filling some values. So let us see. First row, as 0 object, no object is included, then what will be the profit? So in these boxes I'll be writing the profit. So there is no profit gained when no object is included. And even when the capacity of the bag is 0, this is the capacity, these are the weights, right? And these are weights and the profits of the objects. So these are the weights, and there is a 0 weight is there, then all these are 0, 0, 0. Next. Now we'll start filling. So for that I'll consider first object. When I consider first object, I'll take this row and I will ignore all other objects. And similarly, when I go to second row, I'll ignore the remaining and I will take the second object as well as the first object. I'll consider the first object also. So it means whenever I'm in ith row, I will consider all the objects in the previous rows also. So for the first row, directly I can fill it. Let us see. First row, what is the weight of the first object? 2. So it can be filled only when the bag capacity is 2. So here. So what will be the profit? 1. So fill 1 here. Then this means this is same value, previous value. Usually we write previous value only if required. Then rest of the cells, the capacity of the bag is increasing, but how many objects I am considering? Only 1. So I don't have anything more to fill in the bag. So only that object I can fill and we will be getting profit as 1, 1, 1 only. I'll fill the second row also, right? Third row also in the same way. Then I will write down the formula. Let us go to second row. I'm going to consider second object. So as I said, when I consider second object, I should also include the first object. So first let us look at the second object. See, the weight of the second object is 3. It can be filled in the bag only if the capacity is a 3. So in this cell only it can be filled. So what is the profit that I'll get? 2. So put 2 here. What about this side? It will be same value as the previous row. Then beyond this, what should come here? So as I said that, when you are taking second object, you should also consider first object. So if I fill the second object also in the bag, total weight required is how much? 5. So this is 5. And total profit will be 3. So both the objects can be filled when the capacity is 5. And the total profit will be 3. So here both of them can be filled. Right? Both of them. I'm considering both of them. So now I have only 2 objects and this is giving for both objects are filled. So rest of the values will be 3, 3, 3. Then what will be the value here? So as this is 2, so this will also be 2. So I can take the previous value or this value, whichever is maximum, I can take the same thing. Now I will fill the third object also. Then for the fourth object, I will show you the formula. Third object. When you consider third object, if you look at these, the maximum weight is this one, and as they are arranged in the increasing order of the weight, so this is weight is 4. So this object can be filled in the bag only if the capacity of the bag is 4. So this will be included in the bag when the capacity is 4. So the total profit that you will be getting is 5. So this is 5. And before that, whatever the previous row values are. So 2, 1, and 0. Now beyond this, let us see. See, when I am on the third object, I should also consider first and the second object also. So if I just check them, this is 4. And if I take these two objects, it will be total 6 weight. Weight is 6. So these two objects I can fill if the weight is 6. Right? So if I want to fill these two, then these two I can fill when the weight is 7. This two I can fill if the weight is 5. And what will be the profit? 3. This object itself is 5. Right? Now, I will consider these two, 6. And the total weight will be 6. So at 6, it will be 6 only. Right? And when I consider these two, so total is 7. 7. And the profit is also 7. So at 7, the profit is 7. When I include all 3, it will be 10. But the capacity of the bag is only 8. So I cannot include all 3. Then beyond this, the value will be 7 only. And before this one, the value will be same as this 5. 5.
आपके पास ऑलरेडी कोई ट्रेडिंग एंड डीमैट अकाउंट है? ज़ेरोधा, अपस्टॉक्स, एंजल वन ग्रुप.
Alright, now I will show you the formula. And I will fill fourth row with that formula. The formula is like this. If I call this table as V, then V of I, comma W, I is the row number, W is the column number, is maximum of V of I minus 1, that is from the previous row I should take. Same value, means previous row value I should take. This is the meaning. Or maximum of this one, or what? V of I minus 1, comma, weight minus weight of an object, Wi, plus profit of an object that you are considering. Now let us follow the formula and fill all these. First one, 4, 1. I will fill 4, 1. So V of 4, 1 is maximum of V of 3, 1. Like this is 4, so this will be 3, comma, V of 3, weight is how much? 1, minus weight of an object. Weight of an object is 5. 1 minus 5, plus profit of that object is 6. Now this becomes 3, minus 4. There is no such location. So that value becomes undefined. So only this value will be defined. V of 3, 1 will be defined. So V of 3, 1 is what? 0. So I should take 0 only. There will not be any such index V of 3, minus 4. Yes, for that I have to take 0 only. So it means up to what I will be getting negative numbers? Up to fifth weight. So till here I should fill these values as it is only. So that's what I was saying, that this can be considered, or this can be considered in fourth. So write down its value and all previous values as it is. So the same thing here, because they will be getting negative. So till fifth weight, before that, I have filled as it is. Now this fifth weight, how to fill, I will show you. For this value, 4, 5, V of 4, 5 is maximum of V of 3, 5, V of 3, weight is how much? 5. Minus weight of this object is how much? 5. Plus profit of this object is how much? 6. Let's see. V of 3, 5. 3, 5 is how much? 5. V of 3, 5 minus 5, 0. V of 3, 0. 3, 0 is 0. Plus 6. So which is greater? 6 is greater. So fill this value with 6. So that means this object is included here. Now 4, 6 I will find out. V of 4, 6 is maximum of V of 3, 6, V of 3, weight is 6, right? And the weight of the object is 5 plus profit of the object is 6. So how much this is? V of 3, 6 is how much? 3, 6 is 6. V of 3, 6 minus 1. 6 minus 5, that is 1. 3, 1. 3, 1 is how much? 0. 0 plus 6. So the answer is both are same only. So take 6 only. Next one, 4, 7. V of 4, 7. Maximum of V of 3, 7, V of 3, weight is how much? 7. So weight of the object is 5. 7 minus 5 plus profit is 6. So this is 3, 7 is how much? 7, this is V of 3, 7 minus 5 is 2. 3, 2. So 3, 2 is how much? 1 plus 6. So this is 1 plus 6. So this is 7 only. Both I am getting 7 of 7. So they are same only. Take 7. V of 4, 8. 4, 8 is maximum of V of 3, 8, V of 3, weight is 8 minus the weight of an object is 5 plus profit is 6. 3, 8 how much? 3, 8 is 7. V of 3, 8 minus 5 is 3. 3, 3 how much? 2. So this is 2 plus 6. So how much this is? This is 7 and this is 8. So answer is 8. So this is how the table is filled. So I have used the formula for a few cells in the last row. And this can also be filled directly also without the formula. Let me show you how to fill this last row directly. I am considering fourth object whose weight is 5 and the profit is 6. So in fifth column, just write 6 its profit. And what to write on the cells before that? Same value as the previous row. This is what you do first. Then, beyond this, now the weight is 5. Beyond this, the capacity of the bag is increasing. So I can include other objects also. So let us check other objects what I can include. In the sixth column, this object is definitely because its profit is maximum, right? 5 plus 2, 7. At 6, nothing will happen. So take 6 only. At 7, I can consider these two. So this is 6 plus 1, 7. Then at 8, when the bag capacity 8, which of the objects I can consider? 5 plus 3, 8. So 6 and 2, 8. So this is 8. So whichever objects that you can consider, you just add them. And in that capacity they are fitting in, you write on the max total profit. So this is a simple method for filling the cells. Instead of following this complex formula, you can follow that method. So I have shown you both. Solution. I have to write down x1, x2, x3, x4 values. Now for finding these answers, actually I'll be taking sequence of decision now. See, the decisions can be taken only if you have the data. Yes, we have kept the data ready. The formula was used for filling this data. Now I have to take the sequence of decision. So how to solve? So actually I have to know which object should be included and which should not be included in the bag. So let us come with the maximum profit, that is 8, the last cell. This 8 is generated only in fourth row. And in that previous row, you don't find 8 anywhere. So it means we got this 8 because of including fourth object only. So include the fourth object. Right. profit is 8. Fourth object is included because 8 is not there in previous row. Now what is the profit of the fourth object? 8 minus profit is 6. So this is 2. Now remaining profit is 2. Now check whether 2 is there in the third row. Now I have to check for the third object. Fourth, then third, then second, and then 1. So third object 2 is there. Yes. As the same value 2 is there in the previous row also. Yes, it is there. So it means it is not because of third object. So don't include third object. Now let us consider second object. Is it 2 there here in the second row? Yes, 2 is there here. Is it there in the first row also? No. So it means this we got because of inclusion of the second object. So take this as 1. So now remaining is 2 minus 2. So 0. Now 0. Was it there in the first object? So I have to consider the first object. Yes, 0 was there in the first object row. Was it there in the 0th also? Yes, it was there in the 0th also. This row also. So it means don't include the object. So this is the solution. So it means which objects are included in the bag? X2 and X4. Two objects are included in the bag. So that is X2 is this one, X4 is this one. So total profit will be 8. So this is the maximum profit of 0 knapsack problem. Next, I will solve it using sets method. Same problem, I will solve it using set method. Now, let us solve it using set method. Set method will try to find all possibilities and pick up the best solution. So, let us see how sets are generated. We will prepare a set of order pair that is profit and weight. So, we'll start with the set 0. Set 0. In this, we say no profit, no weight. Means nothing is included in the bag. Then we will consider the first object, that is 1, 2, whose profit is 1 and the weight is 2. So, consider the first object. So, prepare S0 of 1 and include this first object in the bag. So, it will be 1, 2. So, actually add 1, to this order pair. So, we get this one. Now, prepare set 1. Then merge these two order pairs and prepare this one. So, this means that we have considered first object. So two order pairs are showing that first object is not included, first object is included. Now let us prepare next set by considering second object. So that is 2 plus 3. So prepare next set, that is S11. So add 2, 3 to these order pairs. 2 plus 3. So this is 2, 3. Then 2 plus 3 is added. So this will become 3 plus 3, 5. Then this is second set for the second object. So when you consider second object, total 4 order pairs. All these are merged. So this is 1, 2 and 2, 3 and this is 3, 5. This means that no object is included. First object is included. Second object is included. Both objects are included. 4 possibilities are there. So all the order pairs we got. Then prepare S2 of 1 by considering third object 5, 4. Add 5, 4 to all. So this 5 plus 4. So this is 5 plus 4 is 5, 4 only. So 5 plus 4. So this will become 6 and 6. So this is 6, 6. 5 plus 4. So this is 7, 7. So 5 is added to this and 4 is added to this. So this becomes 8, 9. 8, 9. Now merge all these and take order pair. So set 3 we get as 0, 0, 1, 2, then 2, 3, then 3, 5. Then 5, 4, then 6, 6, 7, 7. Now here, 8, 9, profit is 8 and the weight is 9. So that is exceeding the capacity of the bag. Don't include that one. So we have discarded that, right? Now, this is set 3. In this one, if you observe, this is profit, this is weight. Profit increase, weight increase. Then from this profit increase, weight also increase. Profit increased and the weight also increased. But here profit increase, weight is decreased from 5 to 4. This is not possible. Profit is increasing, so the weight is also increasing. But weight is decreased. How it is possible? So that's why this order pair are wrong. So we have to discard anyone. So we will discard the one with the lesser profit, smaller profit. So 1, 2, 3, 4, 5, 6. Now we have only 6 order pairs because 2 were invalid. This was giving wrong values and this was exceeding the capacity of the bag. So cutting off this one, we call it as a dominance rule. So with the dominance rule, the value is order pair is discarded. Now I will consider fourth object 6, 5. I will include. So I will prepare set 3, 1 by considering fourth object 6, 5. So first order pair is 6, 5. Next order pair is 6 and 5 are added. So this is 7, 7. And then 6 and 5 are added. So this is 8, 8. And then 6 and 5 when they are added, it will become 11, 9. 6 and 5 added, so this becomes 12, 11. And 6, 5 and added to 7 and 7, so this becomes 13, 12. Now I have to prepare set 4. This is the final set. Merge these order pairs. So 0, 0 is taken from here, 1, 2 and 2, 3 and 5, 4, 6, 6 and 7, 7. They are coming as it is. Now in this one, 6, 5 is there. So 6, 5 should come before 7, 7. So 6, 5. Now here again you see the profit is remaining same, but the weight is reducing. So this should be removed. Then 7, 7 is there. Then 8, 8 is there. Then remaining 11, 9 exceeding the capacity of the bag, 9, 11 and 12. So all 3 order pairs are gone. So these are the order pairs I have. So if you observe, the method is generating all possibilities. So this is one easy method of finding all possibilities. So the time taken by this one is almost 2 power n. Now what is the solution? So we have already sets. Now we take the sequence of decisions to solve this one. Now what is the maximum order pair? 8, 8. So 8, 8. Now using that, I will solve this one. So the approach is similar like what we saw in the tabular method. 8, 8 belongs to set 4. But 8, 8, check whether it belongs to set 3. In the set 3, 8, 8 was not there. So it doesn't belong to set 3. Therefore, fourth object is included. Because of that only we got 4, 4. Now I should take an order pair 8, 8. From this I should subtract the profit and weight of the fourth object. So this is profit is 6 and the weight is 5. So the order pair is how much? 2, 3. So now I should consider 2, 3. So now this was the first one. Now second one. 2, 3. Now I have to consider third object. So check whether it belongs to S3. 2, 3. Yes, it belongs to S3. And 2, 3 belongs to S2. Check whether it belongs to S2. S2, 3 is there here also. It means this is not because of the third object. So therefore, third object is not included in the bag. Then now next step is I will consider second object. 2, 3 belongs to set 2 for second object 2, 3. Now does it belong to set 1? But 2, 3 doesn't belong to set 1. So 2, 3 was belonging to set 2 and 2, 3 doesn't belong to set 1. So therefore, this is because of the second object that is included. Now, what is the profit and weight of the second object? 2, 3. So when you subtract 2, 3 from this one, 2 minus 2 is 0 and 3 minus 3 is 0. So this gives 0, 0. Now, first object I will consider. Now the step is 4. So 0, 0 belongs to set 1 and also 0, 0 belongs to set 0. Therefore, first object is also not included. 0, comma 0 belongs to S1 also, S0 also. It means this is obtained not because of the first object, so first object is also not included. Then the solution is from bottom if you see 0, 1, 0, 1. So the answer is 0, 1, 0, 1. So these two objects are included. See, the profit is 8. So we got the same solution with the help of sets also. So this is one more method. That's all about zero knapsack problem. Leave a comment and let me know whether it was easy for you to understand. So I have shown you both the steps for solving zero knapsack problem. Right? In some places we find tabulation method and some places we find the sets method.
हेलो, होला, बॉन्जूर। जी हाँ, मैंने आपको 3 भाषाओं में हेलो बोला।
Hi, the topic is zero knapsack problem using dynamic programming. Already I have one video on this problem where I have explained how the dynamic programming approach is used for solving zero knapsack problem. There I have shown more than one methods. But here I am going to discuss the program for that one. So I have written a program and I will trace the program and solve the problem so that you get the idea how to write a program for this type of problem. You may be aware of the problem that a knapsack problem is a bag is given, you have to include the objects in the bag such that the capacity should not increase, and when you include the bag, you'll get the profit. And you should include the complete object or don't include it at all. Now, for solving this one, I have taken one instance example here. So inside the program, if you see, look at the program, this is the data that I need. I need array of profits, array of weights, and the number of objects and the total capacity of the bag. Now, one thing to observe here is I have only 4 objects, but the array size I have taken 5. Because we want to start counting from 1. First object will not call it as 0, we will call it as 1. That is the reason I am taking 0th index, empty, that is 0, this is also 0. Now for solving this problem, we need a table. So that table size should be of 5, 9. So 5 is 0 to 4 for 4 objects, and the 9 is 0 to 8 for 8 weights. So whatever the capacity is, you should
ఓకే, ఇది బెల్మన్ ఫోల్డ్ ఆల్గోరిథం. దీనిలో ఉన్న అడ్వాంటేజ్ ఏంటి అంటే ఇది రిజిస్టర్ ఆల్గోరిథం లాగానే అన్నిటినీ చూసి ఎఫెక్టివ్ పాత్ ఏదో చెప్పుద్ది. బట్ ద థింగ్ ఏంటి అంటే రిజిస్టర్ ఆల్గోరిథం మైనస్ వెయిట్స్ని క్యాలిక్యులేట్ చేయలేదు. బెల్ఫోర్డ్ చేయగలదు. షార్టెస్ట్ ఫోర్డ్ ఆల్గోరిథం అలాగే ఇది ఎట్లా చేస్తుంది అంటే knapsack ప్రాబ్లం లాగా. shortest code consider problem solving. Draw a table with the n+1 number of row and w plus 1 number of column. Fill all the boxes of 0 row and 0th column with the zeros as start filling the table row wise top of the bottom from the left to right. Using formula v of I comma w is equals to max of v of I minus 1 comma w, v of I minus 1 comma w minus w of I plus b of I. Here v of I comma w is equals to maximum value of the selected items if we can take items 1 to I and weights restrictions of w. This steps leads to completely filling the table. The value of the last box represents the maximum possible value that can be put into the knapsack. The knapsack is to obtain the maximum profit. Consider the last column of the table. Start scanning the entries from the bottom to top. On the encountering an entry whose value is not as same as the value stored in the entire entry, immediately abort it. The mark the row label of the entry. After all the entries are scanned, the marked labels represents the items that must be put into the knapsack. Example 0 by 1 knapsack problem. M is equals to 8, P is equals to 1, 2, 3, 1, 2, 5, 6. Profit వచ్చేసి 1. వెయిట్ M 8 అయినప్పుడు ప్రాఫిట్ వచ్చేసి 1, 2, 5, 6. N is equals to 4 అయినప్పుడు 2, 3, 4, 5. If max of v of 3 comma 5 ఉన్నప్పుడు v of 3 comma 5 minus 5 plus 6 ఉన్నప్పుడు max of 5 comma 0 that is equals to 5. 4 comma 6 ఉన్నప్పుడు ఇట్లా వస్తుంది. 4 comma 7 ఉన్నప్పుడు ఇలా వస్తాయి. 4 comma 8 ఉన్నప్పుడు 8 వస్తుంది. సో ఇది టేబుల్ ఇందాకట్లా స్నాప్సాక్ ప్రాబ్లం తీస్తే. తర్వాత ఆప్టిమల్ బైనరీ సెర్చ్ ట్రీ అనమాట. A set of integers that are given in the sorted order and another array to frequency. Our task is to create a binary search tree with those data to find the maximum cost of all searches. ఇప్పుడు కీ ఏంది 1 2 3 4. కీ వచ్చేసి 10 20 30 40. ఫ్రీక్వెన్సీ ఏంటి 4263. ఫార్ములా ఐ వచ్చేసి m in of c I comma k minus 1 plus c C of k comma z plus w of I టేబుల్ ఇది టేబుల్ మ్యాట్రిక్స్ చేయ మల్టిప్లికేషన్ లాస్ట్ వావ్ ఆప్టిమల్ బైనరీ సెర్చ్ అంటే టోటల్లో మధ్యలో నెంబర్ తీసుకొని ఆ తర్వాత మిగిలిన ఆ రెండిట్లో మధ్యలో నెంబర్స్ తీసుకొని ఆ తర్వాత మిగతా నెంబర్స్ తీసుకోవడమేనా వావ్ ఈవెన్ క్వశ్చన్స్
Tree. In this video, I am going to talk about what is binary search tree. Then, what does it mean by optimal binary search tree? The problem. Then, the dynamic programming approach for solving this problem. So I take an example and I will solve it. And I will also use the formula and show you how the formula is generated. My focus will be on showing you how dynamic programming is working on this problem, right? Instead of just showing you a shortcut how to fill up the table and get the answer. Let us start with binary search tree. See, the set of keys are given here and the purpose is to search the keys. If already I have the list of elements and I want to search some element. So there are different search methods like linear search and binary search. And also we have a data structure called binary tree. Can we utilize binary tree for searching purpose? Let us see. I will arrange these elements in the form of a binary tree. So I will create a binary tree out of these elements. So I'll keep root as 40 and 20 as left child and 10 as its left child and 30 here, 60, 50 and 70. Now you can see that the elements are arranged such that for any node, all the elements on its left hand side are smaller, all the elements on its right hand side are larger. For 40, all these elements are larger, and for the 60, this element is larger and this element is smaller. Likewise here also. So the benefit of arranging this type of binary tree is that it is useful for searching. Suppose I want to search for a key element 50, then I can start from here. Is it 50? No, 50 is greater than this one, so definitely it's on the right hand side. Go here and check it. Is it 50? No, the key value what I'm searching is smaller than this one, so on the left hand side, yes, key is found. So that's how. What is the time taken for searching a key element? The maximum time will be if the element is in the leaf. So what is the amount of time? So this is height of a tree, and the height of a binary tree is minimum log n, and this is minimum height only. So the time taken for searching in a binary search tree is log n. Now one more thing you have to consider here. When I'm searching for the key like 50, I got the key. Suppose I'm searching for a key element that is 45. Is it there? No. If I search for it, 45 is greater and 45 is smaller than 60, 45 is less than 50. So my search will terminate here and the search is unsuccessful. So search may be successful or search may not be successful. That is, it may be unsuccessful when you're searching for the keys. Now next, I will show you for a given set of element how many different binary search trees are possible. I have taken just 3 keys. Let us see how many different binary search trees are possible. So for these 3 keys, 10 as a root and 20 as its right child and 30 here. So 10, 30 and 20 on the side. 20, 10 and 30 on the side. So for 3 keys, there are 5 different binary search trees possible. Right? So for n keys, how many different binary search trees are possible? 2n cn by n plus 1 binary search trees are possible. So for 3, this will be 2 into 3, c3 by 3 plus 1, this will be 5. So 5 different binary search trees are possible for 3 keys. For n number of keys, these binary are possible. We'll see what is the cost of searching in each tree. See, the cost is dependent on the number of comparison required for searching for a key element. So in this tree, if I'm searching for this key element, then the cost is 1. If I search for this one, then I have to make 2 comparisons. And if I have to search for this one, I have to make 3 comparisons. So what is the average number of comparison? Average number of comparisons are, there are total 3 nodes, so this is 6 by 3, that is 2. Likewise, if I consider all of them, then this is 1 and this is 2 and this is 3, so this is 1 plus 2 plus 3, that is 6 by 3, that is 2. And here it is 1 and this is 2 and this is 2, so this is 5 by 3. So this is less than 2, right? And this is 1 and this is 2 comparison and 3 comparison, so this is 6 by 3. 1 comparison, 2 comparisons and 3 comparisons, so this is also 6 by 3. So you can see that out of these 5 trees, one of the tree I got less number of comparisons. That's average of comparison is less. So that's what, this is a balanced binary search tree. So why we got less is the height of this tree is less. So that's why this is balanced binary search tree. So I've shown you what does it mean by height balanced binary search tree. Now let us come to the actual problem, that is optimal binary search tree. So in this problem, we consider that if these are the keys available, then we also consider what is the frequency of searching of those keys. If the keys are having some frequencies of search, let us say the frequency of searching 10 is 3 and this is 2 and this is 5. So this means that all the keys will not search them with the same frequency. Some keys are there that are more frequently used, so we search them more frequently, more often, and some are rarely used. So like that, who is having highest frequency? 30 is having highest frequency. Then if the frequencies are defined for each key, then what will be the cost? So I want to know which tree organization will be optimal or better. So let us check them. So the number of comparisons required for this one is 1, but its cost is 3, frequency is 3, and this frequency is 2, and this frequency is 5. So how much this will be? 15 plus 4 plus 3, 18.
and this is a 3, and this is a 2, this is 5, and this is a 2. So this is 10 plus 6 plus 3, so this is 19. And here the frequencies are, this is 2, and this is, the number of comparisons are 2, and its frequency is 3, so this will be 3 into 2. And the number of comparisons required, that is the level, is a 2, and its frequency is 5. So this is 10 plus 6 plus 2, this is 18. And here it is a 5, then 10, that is a 3, and this is a 2. So this is 5 plus 6 plus 6, so this is 17. And this is 5 into, this is 2, and this is 3. This is 9 plus 4 plus 5, 18. Now the cost of the trees are different. You can see that this tree organization has given us best result. So that is optimal binary search tree for these 3 keys. Though it is not height balance, this was height balance. Now the height is more, but based on the frequencies, that cost of that binary search tree is minimum. So that's what the problem is. If the keys are given and the frequencies are given, we have to find out which tree organization will be optimal based on the frequencies. Now I will take a problem and I will solve it using dynamic programming approach. Here I have keys 10, 20, 30, 40, and their frequencies are given here. For finding out optimal binary search tree for these set of keys, I have created a table here. I will fill in the values in this table, and then that will help me to generate a table. Here the keys are 1 to 4. Now the table, you can see that it is starting from 0 onwards, right? But the keys are starting from 1 onwards. I have taken from 1 onwards, this is from 0 onwards, so that it's suitable for formula. Let us see how to solve this problem. Let us call these rows as I and columns as j. Now first of all, we will find out those values which are j minus I is equals to 0. So for which values it will be, j minus I will be 0. This is 0 minus 0 is 0, 1 minus 1 is also 0, 2 minus 2, 3 minus 3, 4 minus 4. All these are 0. So it means I'll find out the cost of 0, 0 and 1, 1 and all these. So it means I'll fill up the diagonal. And for the diagonal, I'll first fill up with all zeros. This is the first step. Now I will find out this diagonal. So in this one, j minus I value should be 1. J minus I equal to 1, then what it should be? So this is 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is also 1, 4 minus 3 is also 1. So this is 0, 1, 1, 2, and 2, 3, 3, 4. So I'll find out the cost of all those. Cost of 0, 1, cost of 1, 2, cost of 2, 3, and cost of 3, 4.
On Tickertape, invest in US stocks starting from $1.
Now we will start filling the values. Now see, 0, 1 means I'll be considering just one key, that is key 1, 10. What is frequency? 4. So the cost is 4. And C of 1 to 2, just ignore this first value and take this one. So this is the key. Second key is 2, and the cost is 2, so yes, this is 2. And this is third key is 30, and its cost is C, that's frequency is C, so the cost is 6. And this is 40, and its frequency is 3, so the cost is 3. So 4, 2, 6, 3. So I got the answers as 4, 2, 6, 3. So I have considered just one node where j minus I equal to 1. Now next we'll go for j minus I equal to 2. Now when this j minus I will be equal to 2, so this will be for 2 minus 0, this is 0, 2, and 3 minus 1, this is 1, 3, and j will be 4 and I will be 2, so this is 2, 4. So for these things, j minus I value will be 2. So it means I'll be considering 2 keys. So I will consider first key and second key first, so that means I will take this one first. Cost of 0, 2, I will find out. This is 0, 2, right? I'm considering 2 keys. So what are those 2 keys? Just ignore 0, start from 1, so key 10 and key 20. What are their frequencies? 4 and 2. Let us see, using these 2 keys only, what is the minimum cost of binary search tree or the optimal binary search tree I can generate just by using 2 keys. So for 2 keys, what are the possible binary search trees? 10 and this is 20. That is, first is the root, and this is, second one is the root, so 10 will be on this side. So what's the cost of this? So directly I will calculate. See, the frequency is 4, and this is 1 time, and this is frequency is 2, and the number of comparisons are 2. So how much this is? 4 plus 4, it is 8. And this is 2 into 1, and this is 4 into 2. So 1 comparison required for this, and 2 comparisons required for this. So this is how much? 8 plus 2. So this is giving 10, and this is giving 8. So which one is minimum? This one is minimum. Minimum cost is 8, and which key is forming a root 1? So I will fill up this value, 8, and the root is 1. Now I will show you how I can apply the formula here. Now before showing the formula, I will use one value, that is weight of 0 to 4, for example. Then this means sum of all the frequencies from 1 to 4. Actually we have frequencies from 1 to 4, but we'll write from 0 to 4, right? We are starting from 0, so that we can make a formula. So C of 0 to 4 means sum of all the frequencies from 1 to 4. So let us see the formula. See, this is, the cost is 8 I got. Now here I was taking root as 1. So this is C of 0, 0 on the left hand side. Then C of 1, 2 on the right hand side. Plus weight of 0 to 2, right? So this is 0 to 2. Let us check from the table what we got. Will we get this value as 8 or not? Let us check. C of 0, 0, how much? 0. Plus C of 1, 2. C of 1, 2 is how much? 2. 2. Plus weight of 0 to 2 means I should add all the frequencies from 1 to 2, 1 and 2. So already I have this 4 plus 2. So 4 plus 2. So answer is 8. Now how the same formula is applicable on this side? See, this one is, I'm taking 2 as a root, so 1 on this side. So C of 0, 1 plus C of 2 to 2 plus weight of 0 to 2. So from the table let us see 0, 1. 0, 1 is how much? 4. Plus C of 2, 2 is 0. Weight of all these, that is 4 plus 2, is 6. So how much this is? 10. Yes, we got the same answer. So either I just check them with the height, I'm getting the same answer, or else I'm using the formula. So I'm not showing the complete formula, just I'm applying it here. So which has given us the minimum result? 8. So that I have written here. Right? Now I have to find out 1, 3. C of 1, 3. Just ignore 1. So start from 2. So 2 to 3. So I'll be taking keys 2 and 3. Already 1 and 2 all finished. So 2 and 3. Because every time we'll be taking just 2 keys. So keys are 20 and 30. And their frequencies are 2 and 6. Now what are the different trees possible from this one? I can make this second one as a key, root. So this side will be 30. Or I can make third one as a root. So this side will be 20. Now what are the costs for this one? This is 2 into 1. And the number of comparisons for this one will be 2. So this is 6 into 2. So how much this is? So 2 plus 12 is 14, and this is 1 into 6, and this is 2 into 2. So this is 4 plus 6, that is 10. Who became root here? Third key. This is the second key and this is the third key. So third key became a root here. So this is 10 and third key became root. I will not use the formula, already I have shown you. Now let me finish another value also. Now next key is this one. This is 2, 4. So 2, 4, C of 2, 4. So ignore 2, we'll be taking third key and fourth key. So third key is how much? 30 and its frequency is 6. Fourth key is 40 and its frequency is 3. Now what are the trees possible? So if I make 30 as a root, then 40 will be on the right hand side, or else 40 as a root, then 30 will be on the left hand side. So two different trees are possible out of this, right? Let me put the cost directly. So the frequency of this one is 6 and the number of comparisons required are 1, and this is 3 and the number of comparisons are 2. So this is 6 plus 2, 6, and that is 12. This is 3 into 1 and this is 6 into 2. Its cost is 6. So this 12 plus 3, that is 15. So who has given us the minimum result? 12 has given us the minimum result. And what is the key here? Third one is the key. So answer is 12 and 3 is the key. So 3 will become a root, third key will become a root. So that's it. We have filled up this diagonal where every time we were considering 2 keys. Now we have to fill up this diagonal and we have to consider 3 keys at a time. Now j minus I equal to 3. So what are the possibilities? J is a 3 and I is a 0. So this is 0, 3. And j is a 4 and I is 1. So this is 1, 4. So these are the two possibilities. So I should consider first 3 keys and then that is 1 to 3 and then 2 to 4. So 3 I should select. So let us see if I select this first one, that is 0 to 3. So just ignore 0 and take the keys. So the keys are 10, 20 and 30. First key, second key and third key. And the frequencies are 4, 2, 6. Now what are the trees possible with these 3? If I take 10 as a root, then on this side I can get 20 and 30. This is one possibility. Or 10 as a root, then 30 and 20. This is another possibility. Just 10 as a root. So 10 is 1 as a root, right? 1 as a root. Then if I take 2 as a root, then what are the possibilities? 20 is here, and on the left hand side is 10, and the right hand side is 30. If I make 30 as a key, that is root here, 3 as a root, third value, then 30 on this side, then left side it can be 20, 10, or 30 as a root, 10, and right side 20. So with the 3 keys, by selecting any one of the key as a root, there are total 5 different trees possible. Now out of this, which one is minimum? Which one is minimum? So for this, I will use the formula directly, right? I will not calculate them. So formula, if you remember this one, sum of the frequency. So we have to take from 0 to 3. So if I find out weight of 0 to 3, directly I will find out how much it is. 4 plus 2 plus 6, so this is 12. So let us use this 12 every time. Alright, so what is the cost of this side and this side and this side? See, here who is root? 1 is root. So if 1 is root, then this will be C of 0, 0 plus C of 1, 3. And plus weight is how much? 12. I'll directly write on this one. Then for this, when 2 is there as a root, so this is 0, 1 plus C of 2, 3 plus 12. And on this side, C of 0, 2 plus C of 3, 3 plus 12. Out of this, I have to select any one of them that is giving me minimum. So that is the cost of C of 0, 3. C of 0, 3. So 0, 0, that is 0, plus 1, 3, how much? 10, plus 12, 22. 0, 1, how much? 4, plus 2, 3, how much? 2, 3 is 6, plus 12. So this is 22. Then 0, 2, how much? 8, plus 3, 3, 0, plus 12. This is 20.
म्यूचुअल फंड तो सही है, पर कौन सा सही है ये डिसाइड करना बिल्कुल मेनू कार्ड खोल के कंफ्यूज होने जैसा है.
So 22 and this is also 22. Which one has given minimum result? This is 20. So 0, 3 is 20. And which root has given us answer? 3. Third root has given us the answer. So this is third root has given us the answer. So third key should be 8. I have to find out next value, this one, for 3 keys, and that is 1, 4. C of 1, 4. So what are the keys? Just ignore 1 and start taking the key from 2 onwards. Second key, so that is 20, and the third key, that is 30, fourth key, 40, and the frequencies are 2, 6, and 3. Right? So I will not draw all possible trees now, directly I will use the formula and solve it. So for that, I will find out the weight. So it's W of 1, 4. So in this, skip 1, and remaining we have to find out. So it's nothing but sum of all these frequencies. So 2 plus 6 plus 3. So this is 11. Now let me use the formula. C of 1, 4 is minimum of C of, second is the root, so 1, 1 plus C of 2, 4. Or C of, third key is a root, so 1, 2 plus C of 3, 4. Fourth key is a root, C of 1, 3 plus C of 4, 4. And at last, I have to add that weight, that is 11. So let me write down these values. 1, 1 is 0, plus how much this is? 2, 4. 2, 4 is 12. 0 plus 12. 1, 2 is 10. 1, 2 is 2. Plus 3, 4 is 3. 3. 1, 3 is 10. Plus 4, 4 is 0. So which one of this is minimum? This is minimum. So this is 5 plus 11 is 16. So cost of this one is 16. Right? So answer is 16. And who gave this? Which was the root here? Here the root was 2 and here the root was 3. This was the root. So 3 is the root again. Now next, j minus I equal to 4, then I should consider 4 keys. So for this, possibility is 0, 4 minus 0, that is 0, 4. So finally I have to find out this one, last one. So for that, all possible binary search trees, from that I have to pick up the best one. That's going to give me an optimal cost. Now, I will directly use the formula and solve that one. So cost of 0 to 4. So ignore 0, I have to take key 1, 2, 3, 4, that are 10, 20, 30 and 40. And their frequencies are 4, 2, 6, 3. Then weight of 0 to 4 will be how much? Add all these. So this is 15. And the cost of 0, 4 will be minimum of. If I consider first key as a root, then this is 0, 0 plus C of 1, 4. Then if I consider this second as a root, then this is C of 0, 1 plus C of second as a root, so 2 to 4. Then third one has a root. So C of 0, 2 plus C of 3, 4. The last one is C of 0, 3 plus C of 4, 4. And in all these, I should add this weight, that is 15. Right? So I will write down their values here. So this is 0 plus 1, 4 is how much? 1, 4 is 16. Plus 0, 1 is 4. Plus 2, 4. 2, 4 is 12. 4 plus 12. This is 0, 2, that is 8. And 8 plus 3, 4 is 3. 3. 0, 3. 0, 3 is 20. Plus 4, 4 is 0 only. So out of this, which is giving minimum result? This is 16 and this is also 16 and this is 11 and this is 20. So minimum answer is 11 plus 15. And who is the root here? 3 is the root here. So answer is cost is 26 and 3 is the root. So this is 26 and 3 is the root. So the cost of optimal binary search tree is 26 and the root is 3. Now I have to generate a tree. Let us generate a tree from this data. This is 0, 4 and the root is 3. So for root of 0, 4 is 3. So if I take a third key as a root, this is the key number, not a key. That's 30 is a key. Is a key number. Then on this side, what we will get? Root of 0 to 2 and this is root of 3 to 4. Now 0 to 2. 0 to 2 is this one. So who is the root here? 1. So for this, root is 1. Then on this side, what I get? Root of, when 1 is the root, 0 to 0. And on this side, root of 1 to 2. Then who is root of 1 to 2? 1 to 2 is this one. 2 is the second key, right? This is the second key. First key and the second key. So that second key is the root. So here is the second key is the root. Then on this side, what it will be? Root of 1 to 1, and this side root of 2 to 2. So for this answers are 0 only. Now 3 to 4. So what is 3 to 4? 3 to 4 is this one. This is fourth key. So this is a fourth key. And on this side, root of 3 to 3, and root of 4 to 4. So for this, all the values are 0 only. So this is a tree. So who should be a root? 30 should be a root. And the left hand side should be 10. The right side of this one should be 20. And the right side of this is 40. That's it. This is the optimal binary search tree. For this, the cost of searching will be minimum based on their frequency of search. Now finally, I will write down the formula that I was using. Cost of I, j is equals to minimum of cost of I, k minus 1 plus cost of k to j plus weight of I, j, where k takes the values greater than I less than equal to j. So the root was not starting from I afterwards. So if this is 0, 4, so we'll start from 1 onwards, ignore 0. That's the meaning. So this is the formula for optimal binary search tree, and the same formula I was using it for filling the table. So that's all about optimal binary search tree problem.
हम हॉस्टल वालों का ना सबसे बड़ा दर्द होता है, खाना ऑर्डर करो तो पूरा बजट उठ जाता है और ना करो तो भूखे मरो। खुद देखो एक काम
The problem is optimal binary search tree. In this video, I am going to talk about what is
బైనరీ సెర్చ్ ట్రీ ఇలా చెప్తాడు. ఇది యాజ్ ఇట్ ఈజ్ ఎగ్జాంపుల్ అలానే ఇదే చెప్పాడు. తర్వాత ఇది డివైడ్ అండ్ కాంకర్. In this step, we will break the problem into subparts. Conquer. It will solve the smaller subparts recursively. If the subproblem is smaller, then we can solve it instantly. Application of the divide and conquer algorithm. Binary search. Applications of divide and conquer algorithm. Binary search, mud sort, quick sort, Strassen matrix classification, Kara, Stubber's algorithm, Stassen's algorithm, Radix algorithm, a greedy algorithm. A greedy algorithm is a problem-solving approach like subtract and conquer, and dynamic programming, which is used for solving optimality problem. One solution out of the feasible solutions, minimum spanning tree, single source shortest path, Huffman coding, optimal merge pattern. Kruskal's algorithm. Kruskal's algorithm is a famous greedy algorithm. It is used for finding the minimum spanning tree, MST, of a given graph. The given graph must be weighted, connected, and undirected. Simple, draw all the vertices on the paper. Connect these vertices using edge with the minimum weight, such as the no cycle gets formed. ఎగ్జాంపుల్ ఇలా ఉంది. దీని ఇక్కడ 1 గ్రాఫ్ చూసా కూడా ఏబిసిడిఈఎఫ్ దీని నుంచి లైక్ కనెక్షన్ లేకుండా లైక్ షార్టెస్ట్ స్పాట్ ఇక్కడ 3 ఉంది, కానీ 2 నుంచి ఈజీగా వెళ్ళొచ్చు. బి నుంచి సికి 3 వెళ్తుంది, బి నుంచి ఏకి వెళ్ళి ఏ నుంచి సికి వెళ్ళడానికి 3 అవుతుంది. సో 3 బి నుంచి సికి ఉండే 3 కనెక్షన్ తీసేసినారు. తర్వాత డి నుంచి ఈకి వెళ్ళడానికి 7 పట్టుద్ది, బట్ సి నుంచి డి నుంచి సికి వెళ్ళి సి నుంచి ఈకి వెళ్తే 9. బట్ 7 తీసేసాడు. ఇక్కడ సి నుంచి ఈకి వెళ్ళే కనెక్షన్ ఉంది, సి నుంచి ఎఫ్కి వెళ్ళే కనెక్షన్ ఉంది, ఎఫ్ నుంచి ఈకి వెళ్ళడానికి 8 పడుద్ది. కానీ ఎఫ్ నుంచి సికి వెళ్ళి సి నుంచి ఈకి వెళ్తే అది ఇంకా ఎక్కువ అవుతుంది. సో మినిమం స్పానింగ్ ట్రీ ఇట్లా ఉంటుంది. ది వెయిట్ ఆఫ్ ద ఎంఎస్టీ సమ్ ఆఫ్ ఆల్ ద ఎడ్జెస్ వెయిట్స్ వచ్చేసి 1 2 4 5 6 8 ఇట్ ఈస్ ఈక్వల్స్ టు 18 యూనిట్స్. వర్స్ట్ కేస్ కాంప్లెక్సిటీ ఈజ్ O of E log V or O of E log E. తర్వాత సింగిల్ సోర్స్ షార్టెస్ట్ పాత్ గురించి ఇచ్చాడు. బ్యాక్ ట్రాకింగ్, హ్యామిల్టన్ సైకిల్, బ్రాంచ్ అండ్ బౌండ్, అండ్ బౌండ్ థియరీ, క్రిస్కల్స్ ఆల్గోరిథం.
The minimum cost of the spanning tree of the following graph by using the Kruskal's algorithm. The diagram they have given. Before solving the question, we need to remember this point. The MST should contain all the vertices n-1 edges. It should be connected, no cycle, and in each step we need to select here shortest edge. And after the first step is here, sort all the edges in the graph by weight in ascending order. After that, the second step is here, select the shortest edge with the minimum weight. Which is the shortest edge is here, VE. We need to connect here. After that, we have to include in the next minimum edges is here. That is the AC. AC is here 3. After that, we have to connect here EF. EF is here 3. After that, BC. BC is here 4. Value is here 4. We selected this is the means. After that, FG. FG is here 4. After that, AB. AB if you selected, it will form a cycle. So it should not contain the cycle. So AB will not come. CD equals to 5 here. CD equals to 5. It will come. And EG. If you join the EG means it will form a cycle. So EG won't come. And next BD. BD also won't come because it form a cycle. Then DE also not come because it form a cycle again. DE. BCE it will form a triangle. DF also not come. And CF also not come. It form a cycle. After that we need to add these all the values. It is the minimum cost of the spanning tree. Thank you.
यूपीआई पेमेंट फेल हो गया, इसलिए दूसरे फेवर मांगना पड़ा. अकाउंट में
The topic is minimum cost spanning tree. So for that, first of all, we'll understand what does it mean by a spanning tree. Here I have an example graph. Graph is represented as G and VE. V is the set of vertices 1, 2, 3, 4, 5, 6, and E is the set of edges. The set of edges are from 1 to 2, and 2 to 3, 3 to 4, and so on. Graphs are represented as set of vertices and edges. Now what is this spanning tree? Spanning tree is a subgraph of a graph. Since I should take the subset of this. So subset of what? Vertices and edges. Both the subset or only one subset? So I should take the subset of edges. Vertices must be as it is. So I should take all vertices. 6. Spanning tree means I should take all vertices. Then how many edges? How many vertices I have? Number of vertices are n, that is 6. So I should take number of vertices minus 1, that is only 5 edges. So spanning tree is a subgraph of a graph having all vertices but only n minus 1 edges. So out of these edges, I should take only 5. So 1, 2, 3, 4, 5. I did not take this one. So the spanning tree. See, a tree will not have a cycle, so there is no cycle here. Yes, there is no cycle here. If this you can say it's a cycle. If you start from one vertex, you can again reach back to that vertex. But here, there is no cycle. Is it possible that I will take this one, but I will not take this? Yes, this is also a spanning tree. I will take this, but I will not take this. Yes, this is also a spanning tree. So which edge to select? That is a choice. That's a choice for a spanning tree. So I can say that S is a subgraph of a graph, where S is defined as set of vertices and set of edges, where set of vertices are same as the vertices of a graph, and edges are number of vertices minus 1. So the number of edges are number of vertices minus 1. This is how formally we can divide in mathematics. We can define this. Now next thing, for a given graph, how many different spanning trees can be generated? I want to know that how many different spanning trees are possible. So see, number of edges are how many? 6. 1, 2, 3, 4, 5, 6. In a spanning tree, I should take only 5. I should take only 5. So 6, C, 5. Out of 6 edges, I have to select 5. How many ways I can do that? So 6, 5, C ways. So 6, 5, C is how much? 6 only. So I can have 6 different spanning trees. Just now you can see it's a simple one that I have skipped this edge. Like this, I can leave one edge, right? And I can form a spanning tree, right? I can take all except this, take all except this, take all except 6 are possible. Suppose if I have one more edge now. Now I have 7 edges and I want to select 5. So how many spanning trees are possible? See, I can have this spanning tree also. Or I can have this spanning tree also. The possibilities are more. But this is 7C5. 7C5. But this edge will form cycle. So how many cycles it is forming? This is one cycle and this is another cycle. So this edge is forming 2 cycles of number of vertices less than 6. So if it is forming number of vertices less than 6, then it will be 7C5 minus 2. So that's it. So what's the formula to know how many different spanning trees are possible from a given graph? So whatever the number of edges you have, you should take all those and see of how many edges you need. You need 5. So 5 is what? Number of vertices minus 1. So this is number of vertices minus 1 and minus number of cycles. we have to subtract number of cycles. I have a graph where the edges are having weights. So this is a weighted graph. This is a weighted graph. I want to know what are the possible spanning trees possible. So I'll draw a few spanning trees. Let us draw one spanning tree. This is vertex 1 and 2 and 3 and 4. So 4 vertices are there. Then how many edges I should take? 4 minus 1, only 3. So I'll select this one. 1, 2, 3. So what is the weight of this one? 5, 3 and 6. So what is the cost of this spanning tree? Cost of this spanning tree is 14. I'll take one more spanning tree. 1, 2, 3, 4. And I'll take these edges. Let us see what is the cost of this. 4, 6, 3. Then what is the cost of this one? 13. I'll take one more spanning tree. 1, 2, 3, 4. And I'll take these edges. This one and this one and this one. 4, 2 and 3. So this is cost is how much? 9. Now, from this example, some observation, we can understand something. If you have a weighted graph and you get different spanning trees, the cost of the spanning trees may be varying. You can get a different cost of spanning trees. Now, the problem is, can I find out the minimum cost of spanning tree? Can I find out the minimum one which gives me minimum? Yes, you can find out. How? You can try all possible spanning trees and then from that you can check whichever is minimum. You can pick up that answer. This is one method. Trying all possible spanning trees will be too lengthy. Is there any greedy method? Yes, the greedy methods are available for finding the minimum cost of spanning tree. If a weighted graph is given, you can find out the minimum cost of spanning tree by following the method without finding out all possible spanning trees. So what are those methods? One method is Prim's algorithm and the second method is Kruskal's algorithm. There are two algorithms for finding minimum cost of spanning tree. I have a weighted graph here and I have to find a minimum cost of spanning tree by following Prim's algorithm. Let's see how Prim's algorithm works through an example. Now, as per Prim's algorithm, he says that from a graph, first of all, you select a minimum cost edge. So the smallest edge in the entire graph is this one. Then, this is the initial one. Now for the rest of the procedure, always select a minimum cost edge from the graph, but make sure that it should be connected to already selected vertices. Now the next minimum is which one? 3 to 4. Don't take that, it will not be connected to 1 or 6. So take only those which are connected to 1 or 6. Means what he is trying to do is always maintain a tree. Prince thinks that if some farther away edge is selected, then it will not be forming a tree finally. So that is the reason he suggested that always select a minimum edge which should be connected. So let us see, what's the next one? So for this connected one are this one and this one. So this 25 and 28, 25 is minimum. So select this 25. Then this 28 and 5 connected to 5 are 22 and 24. So out of this 28, 24 and 22. So from 1 and 6 and 5 I'm checking. So already 6 is over. So 1 and 5. So out of those, this is the smallest one. So 4 is selected. Now from 1, 6 and 5, 4, who is smallest? The connected one. So this is 24 and 18 and 12. So 12 is the smaller. So we will take 12. Then out of all these, which connected is the smallest? So here I have 24, 18 and 16. So 16 is the smaller. So take that 16. Then out of all these, who is next connected? So from 2 to 7 there is an edge which is connected. So this is 7. That's it. There are 7 vertices. So 1, 2, 3, 4, 5, 6. 6 edges are selected, and this is how we got a minimum cost spanning tree. And this is how we got a minimum cost spanning tree. What is the cost of a tree? The cost of a tree is, if I add all these, it is 99. So the approach of Prim's is initially select the smallest one, then always select the connected smallest one. Alright? So this is the method of Prim's algorithm.
यार सेम प्रॉब्लम every month man. सैलरी आती है और पता भी नहीं कहाँ चली जाती है.
कैसे? रेंट में?
Next, if I have a graph 1, 2, 3, 4, 5, 6, 7. If I have a graph like this, which is not connected, there are total 7 vertices, but there are 2 pieces in a graph. Can Prim find out the minimum cost of spanning tree for this one? No, no algorithm can find out, because we cannot find a tree for this one, spanning tree for this one. In a spanning tree, it must be connected. So for non-connected graph, we cannot find spanning trees at all. But if I start Prims on this one, starting from vertex 1, if it is starting, then it may find the spanning tree for only one component, not the other component. Next method for finding minimum cost of spanning tree is Kruskal's method. This also follows a greedy approach. Instead of trying out all possible spanning trees, it shows a procedure by following which we can get a minimum cost of spanning tree. It says that always select a minimum cost edge. Always select a minimum cost edge. Let us follow this one. Select smallest edge 1 to 6. That is 10. This one is the smallest. And the next smallest test is 3 to 4. So the second edge I'm selecting is 3 to 4 and its cost is 12. Next minimum is 2 to 7. Select 2 to 7 and this is 14. And the next minimum is 2 to 3. That is 16. And after this, the next minimum edge is 7 to 4, but that is 18. If I select that, it will form a cycle. Yes, Kruskal method says that always select a minimum cost edge, but if it is forming a cycle, don't include it in the solution. Discard that edge, don't include an edge. So it means always select such that it is not forming a cycle. So if I include 4 to 7, it will form a cycle. So next one you check. So the next one is 22. So this is from 5 to 4, or 4 to 5. So this is 22. Next minimum is 24. So that is 7 and 5. If I include this also, it will form a cycle. Don't include that one. Then the next minimum one is 25. That is from 5 to 6. So this is 25. And the cost of this one is, if you add all these weights, it's 99. So here also I got the same result, just how I got in Prim's algorithm. So the Prim's algorithm and Kruskal algorithm has given the same result on this particular graph. Now time taken by Kruskal's algorithm, how much time it takes? See, it has to always select a minimum cost edge from the set of edges. So let us say there are e number of edges. So out of these edges, it will find out the minimum one. And how many such edges it will be selecting? It will be selecting v minus 1. That is number of vertices minus 1. So like we know in a spanning tree, if there are 7 vertices, we need 6 edges for forming a spanning tree. So that's 7 minus 1. So as many vertices we have minus 1, number of edges we have to select. So the total time will be theta of v into e. There v is number of vertices and e is number of edges. So it is n into e. N is the number of vertices and e is the number of edges, which can also be written as n square. If we say both are n, then it is n square. So the time taken by Kruskal's algorithm is n square. But Kruskal algorithm can be improved. When we have to always select a minimum cost edge, then there is one data structure which will always give you minimum value. That is min heap. If min heap is used, then min heap will always give you a minimum value. Whenever you delete a value, you get a minimum value. So if all these edges are kept in a min heap, whenever you delete, you will be getting a next minimum edge. So you don't have to search. So from min heap, whenever you delete, the time taken is log n. So how much time it will take for finding a minimum cost edge? Log n time. So how many times you have to do that? That is n time, number of vertices minus 1 time. So n. So by using min heap, the time complexity of Kruskal's algorithm will be n log n. So that's how Kruskal algorithm can be made faster. Now, if there is a graph given that is not connected graph, it is having two components, 4 vertices on this side, 5 vertices on that side. Can we find a spanning tree on a non-connected graph? No, spanning tree is not possible. But what happens if I run a Kruskal's algorithm? So Kruskal's algorithm will try to find out total number of edges, that is 9 minus 1. So it will try to select 8 edges. And it will not be forming a spanning tree for entire graph, but it may be finding the spanning tree for each component. Let us say the first minimum, the one it will select is this one. Then the next minimum it is having more than 1 edges. Let us say it selects next minimum, and the next minimum it will select this, next minimum it selects this, and this is the next minimum. So in this way, it is selecting the minimum edges from both the components, or it will be selecting from all the components. So it may be finding spanning trees for all the components, but not for the entire graph. So Kruskal algorithm may work for non-connected graphs also, but it may give spanning tree for those components. Let us take a problem here. A graph is given and the weights of the edges are also given, but here two edges are not having their weights. If I take only these edges which are having a weight, they are forming a spanning tree of a graph. Just hide these two edges, it becomes a spanning tree. Now the question is, what could be the minimum values of these two edges? What could be the minimum possible value? Maximum it can be anything, but at least what could be the value? See, as this is included in a spanning tree, this is included in a spanning tree, this is not included because it is forming a cycle. So it is forming a cycle, if it is included, this will form a cycle. So it may be considered after selecting these two, So the weight of this could be 4. Right, first this is selected, then this is selected, then this is not selected, means definitely it is 4. If it is less than 4, then that would have been selected first, right? So it came later, so it is forming a cycle, so it is not taken, then this 4 is taken, then this 4 is taken, this 5 is taken. So then what could be the minimum weight of this one? So it is not selected, at last it is left over, means minimum weight of this one could be 6. So this is 4 and that is 6. So if any missing edges are there, you can find out these type of problems you find in examinations. So some missing edges you can find out. So if you know spanning tree, you can answer this type of question. Let us take this example and let us find out spanning tree for this one. Minimum cost is spanning tree. So if I follow Kruskal's method, so first I will select the minimum cost edge, this edge I have selected. Then the next minimum is this tree and that tree, so I can select anyone. So I'll select this one first. This selected. Next, I'll select this one. So is it forming a cycle inclusion of this one? No. So I'll select that one. Then which other edges? 4 and 4. These two are there, so I can select anyone. So I'll select this one. Whether this will form any cycle? No. So total how many edges I have selected? 1, 2, 3, 4. And total how many vertices are there? 5 vertices are there. So 4 edges are selected. That's how I got a spanning tree. So what's the cost of the spanning tree? 2 plus 3 plus 3 plus 4. And this is 12. Spanning tree is a minimization result. So definitely there will be only one result. So for a problem, there can be only one optimal solution. So we should have exactly one spanning tree only. There cannot be more than one spanning tree, right? But in this example, you can see instead of taking this 4, this edge, I can take this 4 also. Now also it's forming a spanning tree. Yes, so I can select one more. But what is the cost? Cost is 12. So cost is only 1. The optimal cost is 12 only. You will get definitely only one answer in the minimization or maximization problem. But for that answer, the set of input may be changing. So either you can include this 4 or this 4. So total how many spanning trees are possible? 2 spanning trees are possible. But what's the minimum cost? That is 12.
Loved by millions for simplifying news, now simplifying finance too. Get quick, concise.
అది Kruskal algorithm. తర్వాత సింగిల్ సోర్స్ షార్టెస్ట్ పాత్ algorithms. Digester algorithm is the various is very famous greedy algorithms. It is used for solving a single source shortest path problem. Digester algorithm work only for the connected graphs. Digester algorithm work only for those graphs that do not contain any negative weight edge. The actual Digester algorithm does not output the shortest path. The Digester algorithm works for the directed as well as the undirected graph. Digester algorithms ఉంటుంది. Step 1 and if the first step those sets are defined, one set contains all those vertices which have been included in the shortest path tree. In the beginning, this set is an empty. In the beginning, this set contains all the vertices of the given graph. Beginning this set is empty, beginning this set is full అన్నట్టు ఏంటిది? Set 2, the two variables are defined as I of y of v, which does not denotes the predecessor of the predecessor of the vertex v, d of v, which denotes the shortest path estimate of the vertex v from the source vertex. Initially, the value of this variable is in set as the value of the variable phi, for which each vertex is a set of nil, that is phi of v is equals to nil. The value of the variable d for source vertex is set to 0, that is d of s is equals to 0. The value of variable d for the remaining vertices is the set of set to infinity, that is d of v to infinity. Step 3 is among the unprocessed vertices a vertex with the minimum value of variable d is chosen. Its outgoing edge or relaxed. After relaxing the edge for that vertex, that's are created in step 01 or updated edge relaxation edge of a comma b. A ఉంది, b ఉంది, s నుంచి a కి వెళ్తుంది, s నుంచి b కి వెళ్తుంది, a నుంచి b కి వస్తుంది. ఇది w d of a, ఇది d of b, w ఉంది కదా. Here d of a and d of b denotes the shortest path estimation. Estimates for vertices and b respectively for the source vertex of s. Now if d of a plus w of less than d of b, then the d of b is equals to d of a plus w and phi of b is equals to a. This is called an edge relaxation. Advantages: this is used in Google Map. It's employed to identify the shortest path. It is very popular in the geographical maps. The telephone networks makes uses of it applications to determine the quickest route. The application for the social networking within a phone network, time complexity O of E log V, space complexity O of V.
Is investing in stock market safe? Everybody has the same question. Well, each step is
Topic is Dijkstra algorithm. This algorithm is of single source shortest path problem. If a weighted graph is given, then we have to find our shortest path from some starting vertex to all other vertices. Let us say I am selecting starting vertex as 1, then I have to find out shortest path to all the vertices. Maybe a direct path or via other vertices. And I can select any one of the vertices as a source vertex. As we have to find out the shortest path, so it's a minimization problem. And the minimization problem is an optimization problem. So optimization problems can be solved using greedy method. Greedy method says that a problem should be solved in stages by taking one step at a time and considering one input at a time to get an optimal solution. And in greedy method, there are predefined procedures and we follow that procedure to get an optimal solution. So Dijkstra algorithm is a procedure for getting an optimal solution, that is minimum result at the shortest path. In this video, I will show how a Dijkstra algorithm works. And the Dijkstra algorithm can work on a directed as well as non-directed graph. And also, I will show you the drawback of Dijkstra algorithm. That is the approach of Dijkstra algorithm. For that, I will show you the basic thing that is followed by Dijkstra. So for that, first of all, I'll take a very small example and show you. To show the approach of Dijkstra algorithm, I have taken a very small graph here. From this, we will understand what is the approach of Dijkstra. If I say 1 is the starting vertex and I want to find the shortest path to 2 as well as 3. So if you see from this graph, there is a direct path to vertex 2, so its cost is 2. And there is no direct path to 3, so we don't know what is the path. First of all, we consider a direct path. But now, if we follow this algorithm, we will be selecting first the shortest path vertex. So this is shortest because this is 2, that is infinity. So we'll select this one. And Dijkstra says that once you have selected one of the shortest path, then check via that vertex, from that vertex, there is any shortest path to other vertices. So let us check who is connected to 2. So from 2 we can go to 3. This is 2 plus 4, that is 6. And right now it is infinity. Yes, this infinity can be changed to 6. This means that there is a shortest path from vertex 1 to 3 of distance 6. No doubt, it's not a direct path. It's coming via 2, but there is a path. That's how the Dijkstra algorithm always select a vertex with the shortest path. Then it will update the shortest path to other vertices if possible. And this updation is called as relaxation. Let me show you how this relaxation works. For that, I will call this vertex as u and this vertex as v. And this is distance of u and this is distance of v. Initially it was infinity, now it is changed to 6. And this is cost of an edge from u to v. So here, relaxation means if the distance of vertex u plus cost of an edge u comma v is less than distance of vertex v. See, here, the distance of u was 2 and the cost of an edge was 4 and this was initially infinity. So this 2 plus 4 is less than infinity. Yes, so we have modified this to 6. So we'll modify this one. That is distance of v is modified to distance of u plus cost of an edge u comma v. This is what we followed, and this is called as relaxation. And we do relaxation for the vertices. Whenever we select the shortest path, we will try to relax other vertices. Now let us follow this procedure and solve this graph problem to find the shortest path. Let us solve this graph problem. For this, I will select this vertex as the source vertex, starting vertex, S starting vertex. Now I will get the distances for all the vertices by considering just single edge. So I will label the distances above those vertices only. This distance is 0, and this distance is 2. This distance is 4. From 1 to 4, there is no direct edge, infinity. From 1 to 5, there is no direct edge, infinity. Similarly, 6 is also infinity. Except 2 and 3 all are infinity. This is the initial thing that we should do for any graph. Now, let us start the repeating steps. Now the steps will be repeating. First step, select the shortest path out of 2, 4, infinity, infinity, infinity. This is the smallest. Select this one. Once we selected this, we should perform relaxation. What is that? Check who are connected. 3 and 4 are connected. Just check the distance of u. That's 2 plus 1, 3. And this is 4. 3 is less than 4. Modify this. Then this is also connected. 2 plus 7. 7 is, this is 9. And this is infinity. Modify this. 9. That's all. Some vertices are relaxed. They may or may not relax, but we should check one. Now second step. Now the step is repeating. Same thing I should do. Select the smallest one. 3, infinity, 9, infinity. Which one is the smallest? Shortest this one. Select this one. Now check if any vertex get relaxed. So there is only one connected. It's 3 plus 3, 6. This is infinity. So change it. Now select the shortest. Out of what? 6, 9, infinity. Which one is shortest? This one. Select this one. And see who are connected and try to relax them. So 6 plus 2 is 8 and that is 9. So this is more smaller. Modified. 6 plus 5 is 11. This is infinity. Modified.
So 2 vertices are modified, they are relaxed. Now, who are remaining? 4 and 6. Who is remaining? 8. Select this one. And check if anything gets relaxed. 8 plus 1 is 9. It's already 11. Modified. So here I have taken an example. Most of the time the vertices are modified, the distances are modified. They may or may not modify. The last one is remaining is 6. So now we have the shortest path from starting vertex 1 to all the vertices. So what are the other vertices? 2, 3, 4, 5 and 6. What are the distances I got? For 2 it is 2 and 3 it is 3 and 4 it is 8, 5 is 6 and 6 is 9. These are the distances of all the vertices and these are the set of vertices. These are DVs and these are vertices. So that's how this algorithm works on a graph to find the shortest path. Let us split it, analyze and find out the time complexity of this algorithm. If you analyze what it is doing, it is finding shortest path to all the vertices. How many vertices are there? These are the vertices. Or we can also say n number of vertices. So for all vertices, it's finding shortest path. While doing so, what it is doing, it is relaxing. Relaxing which vertices? When it is on 3, it is relaxed. It has relaxed only 5. When it was on 2, it has relaxed only 3 and 4. So total how many vertices it may be relaxing? We don't know, it depends on the graph. Okay, at most how many vertices it may be relaxing? All n vertices. Suppose 2 is connecting to all, then it may be relaxing all of them, it may be checking all of them. So again, it is V. So it means n into n. N for vertices and n vertices are relaxed. So it will happen that from 2 all are connected and again 3 all are connected. That will be a complete graph. In case of complete graph, it will take n into n time and this will be n square. So this is the worst case time of Dijkstra algorithm. Maximum time it may be order of n square. I can write it as theta of v square or theta of n square, the worst case time, and I can use theta there once I know that function that is n square and it belongs to some class that's n square class, quadratic class. So this is theta of n square. Here I have a weighted directed graph commonly found in textbooks. On this we will run the Dijkstra algorithm to solve single source shortest path problem. So I will not be updating the distances upon the vertices itself, but I will be writing them in the table. So let us see how I can prepare this table. So instead of writing there, I'm writing here. So initially I should find the directed paths to all the vertices. So for 2 it is 550, 3 it is 45, likewise all the paths are given. And one thing to mention here, the starting vertex is 1. So in the graph you can see 1 to 2, 50, 1 to 3, 45, 1 to 4, 10, 1 to 5, no edge, 1 to 6, no edge. So 50, 45, 10, infinity, infinity. Already given. Let us solve it. The smallest vertex is 4, so I will select vertex 4. So the selected vertex is 4. Then once the vertex 4 is selected, see from 4, 5 is connected. So can we relax this one? So 4 is a 10, 10 plus 15, 25. Yes, 5 can be modified. And we got a path that is infinity, so it is 25 now. And this remains infinity. And this is 10, which is already selected. 45 and 50, they remain as it is. Now select the next smallest one. So this one. Vertex 5 is selected. So vertex 5 when it is selected, there is an edge to 3 and there is an edge to 2. So if I take 2, how much is 5? 25 now. So I did not mention here. 25 plus 20, 45. And this distance is already 50. This is 50. But now we have a shorter path via 5, that is 45. So modify this 45. And this is also 45. This 10 is selected, 25 is selected. This still remains infinity. Now I have to select the next shortest one. So I have 45, 45 infinity. So I can pick up any one. So I'll select the second vertex 2. Once vertex 2 is selected, from there the connected vertex 3. So plus 10. 45 plus 10, 55. But already the distance to 3 is 45. So 45 plus 10 will be 55. So this is smaller, no change. So this remains as it is. 45 is already selected, this remains 45 only. 10 is selected, 25 is selected, and infinity. Now select next minimum. So 3 is selected. Now from 3, there is an edge coming towards 5. But 5 is already in the selected vertex. Don't check it. If you check also, it's of no use. See 3 is how much? 45. 45 plus 30 will be 75. So already 5 is having its weight as distance as 25. So no use of checking it. So nothing is relaxed and this is selected. That's all. So 45 selected, 46, this was selected, 10 selected, 25 selected, infinity. Now who is remaining? Infinity is remaining. So 6 is also selected. So the path to vertex 6 has remained infinity only because there is no incoming edge on 6. So we cannot reach 6. The path to vertex 6 is infinity only. So this is how Dijkstra algorithm works. Dijkstra algorithm can work on non-directed graph also. Suppose you have a graph, simple example I will take here. Simple example I have taken here. Now how it works on this one. So if you're not comfortable with the non-directed edges, you can convert them into directed by adding parallel edges. So you can say this is a 3 and this is also 3. Now it becomes a directed graph. So you can convert a non-directed graph to directed graph, right? So it can work on both directed as well as non-directed graph. Now I will show you the drawback of Dijkstra algorithm. Let us see the drawback of Dijkstra algorithm. For that I have taken a very simple graph and it is having a negative weighted edge. The weight of this edge is negative. So weight of an edge, how it can be negative? See, it is not distance. So distance is not measured in positive negative, right? But any problem or any business problem, we can represent it using graphs. Like usually when we want to explain something to our friend, then what we do, we just take a paper and draw something. So what is that? It looks like a graph only. So most of the problems from real world are mapped in the form of a graph. So when you are representing something in the form of a graph, it may have positive and negative values also. So this is not exactly distance that is measured by tape, but this is some value. So those values can be negative also. So actually Dijkstra has not considered that if there are negative edges, then what we should do. He has not considered. Let us see what happens if you follow his procedures on this one. Let us start. If I say this is the starting vertex, then the distance is 0, then the direct edge path is 3, and the direct edge path is 5, and there is no direct edge path, so this is infinity. This is the initial setup of Dijkstra. Now let us solve this one. Which one I should select? The smallest one. The shortest path is 2. Select this one. Are there any connected vertices to this one so that I can relax? No, there is no outgoing edges from 2. Leave it. Next, select the next smallest. So 5 and infinity, so 5 is smallest. So select 4. If you select this 4, then will it relax any vertex? Yes, the connected vertex is 3. So what is that path? 5 plus 2, 7. So this is 7. Now, both are selected. Third one is remaining. Select that one also. Once this is selected, shall we relax that one? No, no need. Already we learned that. When already vertex is already relaxed, no need to check it. Let us check it once. 7 minus 3 is 4. No, already it is 3. So that's there. So all the things are perfect. The answer is perfect. So Dijkstra algorithm has worked even when there is a negative weight edge. Now I'll make a small change. I'll restart again. I'll start over again, and now I will make this edge as minus 10. Let's see what happens now. I'm again finding the shortest path to all the vertices. This is the source vertex, so it is 0, and this is 3, and this is 5, and there is no direct edge path, infinity.
Find model portfolios under ₹50. Created and managed by SEBI registered investment.
I'm performing this once again because I have changed an edge. Now let us see. Select the minimum one. So 2 is minimum selected. Anything get modified? No. Next minimum is this one. Anything get modified? That's 5 plus 2 is 7. Modify this. Next minimum is this one. And this is the last one. Shall I flag that? No, it's already selected. But let us check it once. 7 minus 10. Minus 3. Now, actually, the path we found was 3. But now we realize that when we come along these vertices and reach here, it is minus 3. So we were in a hurry to select the shortest path to vertex 2 and we selected it as 3. It was wrong. If we would have tried the other way, we would have got the better answer. So actual correct answer is minus 3, but Dijkstra has given us the wrong answer and also asked us not to check those vertices which are already relaxed. We should not check them because no need to check. You will not find any better answer. But here we are finding a better answer. The reason is we have a negative edge. So Dijkstra algorithm may work or may not work in case of negative edges. That's all about single source shortest path problem, and the approach was greedy. You can see the greediness here. See, it is not trying all possibilities and selecting the minimum one. It found that this minimum selected. Right? This is what the greedy approach. So greedy approach has failed here when there are negative edges. Alright, there's another solution for this single source shortest path problem, that is Bellman-Ford's algorithm. We will see that in dynamic programming. Alright, so next video will be on dynamic programming. These are the topics I have covered from greedy method. Leave your comments so that I can know how you are following the videos. Right? If any suggestion, just give me. I'll try to implement them in my next videos.
then the p factorial is equals to np, but till the date it is not possible to find out whether np is equals to p or not. Status of the np is still unknown. ఇది హ్యామిల్టోనియన్ సైకిల్ అనమాట. తర్వాత ఇది బ్రాంచ్ బౌండ్, ఆప్టిమైజేషన్ వాల్యూస్ ఆఫ్ సెట్ ఆర్ ఎన్, ఇది లోయర్ బౌండ్ అనమాట. తర్వాత ఇది నాన్ డిటర్మినిస్టిక్ చాయిస్, ఇది ఎన్పి హార్డ్ అండ్ ఎన్పి నాట్ కంప్లీట్, ఎన్పి పోలినామియల్ టైమ్ లీనియర్ సర్చ్ కి ఎన్, బైనరీ సర్చ్ కి లాగ్ ఎన్, ఇన్సర్షన్ సార్ట్ కి ఎన్ స్క్వేర్, మర్జ్ సార్ట్ కి ఎన్ లాగ్ ఎన్, మ్యాట్రిక్స్ మల్టిప్లికేషన్ ఎన్ క్యూబ్. అది ఎక్స్పోనెన్షియల్ టైం వచ్చేసి ఎన్పి కంప్లీట్ అనమాట. 0/1 అది ఎన్పి హార్డ్ కాదు. ఈ 0/1 క్నాప్సాఫ్ట్ ఐ మీన్ ఎక్స్పోనెన్షియల్లో 0 or 1 క్నాప్సాఫ్ట్ వచ్చేసి 2 power n, ట్రావెలింగ్ సేల్స్ మ్యాన్ వచ్చేసి 2 power n, సమ్ ఆఫ్ ద సబ్సెట్ ఇస్ 2 power n, గ్రాఫ్స్ కలరింగ్ సైకిల్ ఇస్ 2 power n, హ్యామిల్టోనియన్ సైకిల్ వచ్చి 2 power n అనమాట. ఇది ఎన్పి హార్డ్, ఎన్పి కంప్లీట్. ఎన్పి అండ్ ఎన్పి హార్డ్ రెండు కలిపి ఎక్కడ ఐ మీన్ రెండు ఉండేది ఎన్పి కంప్లీట్ అనమాట. అంతటితో దీన్ని ముగిద్దాం.